this part is done, forms the basic of the press brake. Go head over to the lathe and get this part roughed out. So for work holding, we are planning to use this clapped out forja chuck. So we have clamped the chuck using 2 strap clamps. I think this is going to be enough. Yeah. So you get the picture, right? How well this is going to fit. Okay, so we think that we have a first casualty. Here is a better picture of the damage. Hey guys, welcome back to part 2. Last time we had to cut this video short because getting a very long video. So we told in the end of the last video is that we have done machining with the V part of the press brake, and now we are in the process of manufacturing the brake from this solid piece of flat bar. So what we need to do is we need to just start with the project where we left off last time. The mill is already indicated to the height which it requires, and now we only need to just clamp the workpiece and let's start machining. So I hope this is visible in the camera that we are using the APMT 1135 same insert. It was making a lot of sound in the last video, and we thought that because this is a carbide end mill, we ran it very fast, and what happened, it was making a lot of noise. So we have slowed down the machine in the last video, as you can see, and we have already the machine is currently running in back here. So let's start with the first part. Okay, so this is going to be the last pass on this side. So we are going to give the depth now. I think a little bit tape more is required. I bring you in close so that you can see. I think what I probably must do is go with another pass. Okay, so what we are going to do now is we are going to clean this general area up, regroup, and then indo the part and start cutting the other end. But before we indo the part, let's show you. This is the side which is machined already. The machining quality is nice, I feel, and we are going to do this edge. So we'll put the part back in. Alright, then clamp it securely, that is, we use the hammer. Okay, and then we'll start. So this part is done, and these two forms the basics of the press brake. All right. So the milling work is done now, and what we need to do is we have this piece, like in the earlier video, like we have said, this is the piece of 45 millimeter round bar, which on one side we need to bore 32 millimeter, which is the ram size of our hydraulic press. The other we are going to machine a 20 millimeter slot in the middle, which we can then insert it into this part and weld this entire assembly to form a complete unit. So let's go head over to the lathe and get this part roughed out. Okay, so starting with the machining of the holder, this part is going to be rough because this is not a machined piece, this is just hot rolled solid steel block. Alright, so we would start with the facing cut first. For that we need to increase the speed a little. Center drill. So this is a 9 millimeter drill that we are going to use for pilot purpose. So this is going to be our first drill, which is the pilot drill. I think we are going to go with a smaller pilot drill. So this is a 6 millimeter pilot drill which we are going to use, and we are going to increase the speed. Use some cutting oil and start drilling. Drill, baby, drill. Now we are going to upsize the drill to the 9.5 millimeter drill which we were using earlier. So let's start. This is a 16 millimeter drill that we are going to use next. For that, we are going to reduce the speed a little. Drill, baby, drill. This is not seated into the taper. Alright. So now it's seated in the taper. So this is a 24 millimeter drill, close to an inch, which we are going to use. Post this, we are going to start with the boring process, which is quite frankly really boring, because we have to expand this from 24 to 32 millimeter or a little more than 32 millimeter for our ram. So let's start hogging with this drill. Probably a little bit of speed reduction is in cards. Yeah. Need to reduce the speed. Alright. So this hole currently, which you will have to measure, is close to around 60 millimeters or 2¼ inch, and maybe we should go just a tad little more to clean the bore. So the bore is now clean. Yeah. So next up, we need to clean all this mess and start with the boring part. Okay, so we have regrouped. Now this is the boring bar, which we are going to use to bore this 24 millimeter part and enlarge it to 32 millimeter or little more than 32 millimeter. So what we need to do, we need to zero out to the end of the part. So it's touching the part now, and we are going to have this to 0. All right. This is touching the base. We need to have this boring bar a little up. Now let's see how it behaves. Alright, so this would go. Let's give another pass. we are going to use some cutting fluid. This will be 28.5. So we are giving 1 millimeter depth of cut in each and every pass. These chips are really deadly. Oh. Those are huge long chips. So this is a sample rebar that we have. The diameter of it is 32 millimeters. You would see how it goes inside. Not quite. So probably a little bit of enlargement we are gonna do. So we will give in 0.5 millimeter more. And because this is the last pass, we are going to use some cutting oil to aid with the surface finish. Alright, last pass. Hope this is the last pass. Now let's check. This is 32 millimeters. Yeah. It's still a little bit tight. Probably all because of surface rust. This does not need to be an accurate bore 32 millimeter. We are only making it clearance so that the ram of our hydraulic press would fit. So in this case, we are going to go another 0.5 millimeter oversize such that it fits beautifully. So we are going to go 0.5 millimeter more. Yeah. So this is as much as we are going to go in this setup. So let me clean the bore first. Mostly the bore is clean because we do not have a shop compressor. We are going to use a magnet to take care of all. Alright. And we are going to take this out from the lathe. So the lathe work is complete. We have not turned the OD of the part because in our cases it does not make much sense. Only it might make the part look nice, but this mill scale finish is good for us only because it helps to prevent further rust. And in the milling machine, let's set up in the milling machine. Probably we have to devise a setup where we can hold this thing very much straight and parallel so that we can mill this end and drill holes for an M10 or a M12 grub screw. So for work holding we are planning to use this clapped out 4-jaw chuck. As you can hear, all these jaws are not in a very good condition. Mostly the inside jaws, the outside jaws are still okay. And we are going to use this primarily because this is round. And if anybody is familiar with vice or milling vice, they are not great for holding round jobs until and unless you get a V block. Tight the vice using a V block. We do not have a V block in the shop, nor do we feel like making one just for this. We are going to make one in the future, but that is not the part of this video. In this video we are going to use this 4-jaw chuck which came from this James lathe. Now many of you, if you have been following this channel for a while, would know that we have made a 3-jaw chuck for this James lathe, which is right over here. The 3-jaw chuck which we have made. So here's the link which is coming for that video if you wish to check that out. Now we have ideally decommissioned this 4-jaw chuck which came with the lathe, primarily because it is not of great use, but we think that this is going to be a perfect opportunity for this chuck because this chuck is clapped out. The only thing that this chuck needs to do is hold this part in securely, and the bore of this is very much I think this will go through the bore because we do not have a 3-jaw chuck for the milling machine, because we want to buy a 125 millimeter 3-jaw chuck for our rotary table. We have not done that yet. So until that comes and we do that, we are going to use this 4-jaw chuck because I think it is going to work perfectly fine. Only thing what it needs to do is to hold the part securely in the jaws. So what was decommissioned is not decommissioned. I think this is going to work fine, and this is the best possible use of the 4-jaw chuck which we could find, and we are going to roll with this. Okay, so we have clamped the chuck using 2 strap clamps. I think this is going to be enough, and this bore of the chuck is a little small. I hoped that it would go all the way in, but it is not. It is registering in the face of the chuck because this is an 18-inch chuck, and the one we have over in this lathe is also an 18-inch chuck. I thought the board is going to be similar, but it is not. This board is a little small. I hope we have a certain amount of vertical clearance to get this job done in one go. This is, I hope, the best. Otherwise we have to find something else to deal with. So we are going to start with indicating the part. We have to bring the table considerably down. So this is x0. So this is x and a half. So we have found the coordinates, and let's see if we have vertical clearance for this big mill, for this big indexable end mill which we have over here. I hope it does. I think we would have room. All right. So first operation which we would need to do is we need to face this entire surface I bring you in close so that you can see as well. I hope it is visible. Sorry, so we could have done this facing part on the lathe, but somehow we forgot. So let's start the other way. Yeah. So we need to bring the table a little bit above such that it touches the part, and now it is. I think the part is faced. We are just to go a little bit more. Okay, so now this is the center line of the part. We are going to lock the y axis, lock the quill, and we need to give some depth and start machining. So we are giving a depth of 1 millimeter each time. Sometimes a little bit of oil goes a long way in ensuring the cuts go smoothly. What we want to see here is the amount of clearance which needs, it's barely fitting in, so it's going to be a snug fit. That's completely fine with us. Yeah, so you get the picture, right? How well this is going to fit. This is gonna fit like this. And okay, so this is not all the way seated, we'll have to hammer it in, but just want to get a general idea of how much depth we are going to go with this. Probably a little more, probably an inch or so, or 25 millimeters. I think it will go up to here. So this will sit like this. Ideally this is what we want, because this material is not very thick, we don't want it to bend or flex. under load. So quite a while to go. So we will meet once we are done with most of the roughing. Okay, so we think that we have a first casualty. Here is a better picture of the damage which this insert has took. Hey guys, so we have lost some recording, so that is the reason why we are recording it and doing a dubbing of this part. So as you can see from the picture that there is a damage on the insert. So what we are doing now is we are cleaning the insert using some cleaner, which is usually a carb cleaner that we have in the shop, and we are removing the bolt or the screw using a torque screw. And then we are going to clean the seat. As you can see, we are cleaning the seat using the carb cleaner that we have. And the last thing that we would do is we are going to put it back. Now since the APMT 1135 has two sides, so since one side is damaged, so we are going to just flip it the other end, and then we are going to screw that in place so that we can continue with the cutting of the press brake holder. So here you can see that we are just tightening it, and once it is done, it is good to go. And we are also cleaning the other, as if one is damaged, likely the other also would. So we are cleaning it and inspecting if that is in proper condition. In this case it is, so we are just ensuring that it is properly tight, and we will continue with the cut. So here is the sample footage of the final few passes that we took with the APMT 1135 insert, and we are checking the overall length or the depth of the cut. Okay, so this is just a mock way that we have put it. We have eyeballed the center. It is not very much center, I know, because this part is a little inside and this part is a little outside. But however, you get the picture of how this is going to look. Last thing before we go and weld this up, which is going to come in the next video, we are going to chamfer this so that we get some weld penetration. So here we are trying to show you the chamfering end mill that we are going to use. Now this is also an indexable chamfer mill which we are going to use to cut the bevels or chamfer, a large chamfer on both ends, such that we can use that for weld penetration. So I realized that we have lost a lot of audio because this microphone decided to shut off, probably because of low battery, and I did not see, but this part is machined, as you can see. Where there is no voice, we are going to provide a voiceover, and we have done chamfers, as you can see, clear chamfers on both ends, such that when we are going to weld this, some amount of weld are going to penetrate in the chamfers, forming a very strong joint. And this is precisely 20 millimeter, the thickness of this edge, and this goes in like the way it has been shown in the video. So with this guys, we are going to wrap up this particular video. I hope you guys enjoyed this video, the press brake build series part 2, and I hope that we are going to meet in part 3, where we are going to finalize this entire build, wrap up the video and do some test bends to see how press brake works. So with that said guys, thanks for joining us. We'll meet you next time in the next video. Until then, keep smiling and God bless.